In this lesson, we're going to discuss trusted operating systems. Now, a trusted operating system, or TOS, is a type of operating system that's designed to provide a secure computing environment by enforcing stringent security policies that usually rely on mandatory access controls. Now, mandatory access controls, or MAC, is going to be used to specify who or what process is permitted to access a particular resource or piece of information. Trusted operating systems are typically used in environments where the integrity, confidentiality, and availability of your data is extremely important. For example, the J-35 strike fighter, which is a U.S. military aircraft, has an operating system that runs all the operations on that advanced fighter jet. The operating system that's used by the J-35 strike fighter is known as Integrity 178B. Now, this is a POSIX-based operating system that's designed for embedded system use, and it's been put in place into numerous aircrafts like the B-2 bomber, the F-16, the F-22, and the F-35 fighter jets, and even commercial airplanes like the Airbus A380. Now, this specific operating system is rated as EAL6, and EAL6 is the evaluation assurance level that's assigned to this operating system based on a set of predefined security standards and certifications from the Common Criteria for Information Technology Security Evaluation. Now, the standards in the Common Criteria are used to evaluate the effectiveness of the security controls that are implemented by a given operating system, and they're rated as EAL1, which is the lowest level of assurance, all the way up to EAL7, the highest level of assurance. Now, trusted operating systems will often include features like mandatory access control, security auditing, and role-based access control to meet these different EAL standards. Now, mandatory access control, or MAC, is one of the key features of a trusted operating system. In traditional discretionary access control systems, or DAC systems, users have some discretion over who can access their data. But in a MAC system, access permission is determined by the policy defined by the system administrators and enforced by the operating system itself. This ensures that even the data owner cannot change the access permissions to provide themselves with higher levels of security. Now, there is also a trusted operating system that we use a lot known as SE Linux or Security Enhanced Linux. This is a set of controls that are installed on top of another Linux distribution like CentOS or Red Hat Linux. And when we're using SE Linux, these systems are rated as an EAL4+. Now, SE Linux is used as an implementation of Mac in the Linux kernel to ensure that applications and users only have the minimum necessary access to your resources. SE Linux uses policies to enforce security properties and can confine potentially harmful processes to limit the impact of the vulnerabilities. The Trusted Solaris operating system is yet another example of a distribution that's configured to use Mac. Trusted Solaris is designed to provide secure multi-level operations while implementing Mac, and it gives us detailed auditing of our system events as well as compartmentalization to isolate our processes and our data. Now, inside of a trusted operating system, we'll often use microkernels that are going to minimize the trusted computing base of that system. Now, the trusted computing base includes all the parts of the system that are critical to security and must be trusted to operate correctly. By minimizing the trusted computing base, though, by using this microkernel architecture, the system's attack surface is going to be reduced, and the likelihood of security vulnerabilities will also be decreased. Trusted operating systems will also exist in the realm of mobile devices. Now, operating systems like Google's Android have incorporated elements of the trusted computing model throughout the use of various security mechanisms, including application sandboxing, which restricts access to system resources and isolates applications from each other by implementing trusted security architecture tools like AppArmor to enforce mandatory access controls on your mobile devices. Now, I'm sure that trusted operating systems sound like a wonderful idea based on all the great security they can provide us. But it is important to note that designing and maintaining a trusted operating system is actually quite challenging and really expensive. So when you're deciding which type of operating system to use, you have to balance your security requirements against your usability, performance, and other functional requirements to ensure that you're balancing the convenience and security for your end users when deciding which operating system to use. Now, for example, ever since Windows 7, every version of Microsoft Windows has been tested and rated at least at an EAL4 or EAL4+ under the Common Criteria system. Additionally, every version of Mac OS since version 10.6 has also been rated as either EAL4 or EAL4+, and many versions of Linux are also rated as EAL4 or EAL4+ as well. Now, EAL4 means that the operating system was methodically designed, tested, and reviewed, and it really does provide us with a really good, decent level of security assurance, but it's not nearly as high as an EAL6 or EAL7. But achieving those EAL levels with a generic operating system like Windows, Mac, or Linux would be too difficult and too costly for the manufacturers to do, so these higher level EAL systems are usually going to involve an embedded or purpose-built operating system like those used in autonomous vehicles, airplanes, and medical devices. So remember, trusted operating systems play a vital role in providing a secure computing environment in contexts where data integrity and confidentiality are crucial. By enforcing strict access control standards, conducting rigorous security evaluations, and minimizing the trusted computing base, these systems aim to mitigate and minimize potential security risks. Over time, as data security and assurance continues to gain an increasingly important role in our organizational networks, you may see more and higher levels of trusted operating systems being used by your organization.